Thanks for Alex's introduction. So we know that the NDN applications, they actually need to be configured in order to play their functions. And Kathy introduced the concept of the VerSec and the identity bundle that one can install it to enable an NDN entity with the security credentials and the corresponding trust schemas. And this talk will focus on how to actually putting those identity bundles into the NDN applications. And actually, we will talk about the bootstrapping process. And so far in the previous talks, Cassie talks about how we can make use of DCT to installing the identity bundle out of band by using the command line tools. And actually, that's based on the assumption that you can physically, say, log in on that machine, or you can have the command line environment, and that direct or physical access achieves the mutual authentication that Alex mentioned between the trust zone controller and the new entity. And that mutual authentication usually, or a direct access, forms a secure environment. In the previous case we talked about, that the office configuration example. However, more entities, they need to be configured or bootstrapped in unsecured environment. So we will explore the next two cases. First, we will look at how to bootstrap a local entity in unsecured environment. Then we go to the remote part. So let's look at a little different one. That how about if the network environment is unsecured, which means you don't have the command line tools to actually install the DCT bundle. So same as case one, the trust zone controller and the new entity, they are at local. Say they are within one hop wireless communication range. And specifically, we can consider the user Alice wants to bootstrap her sensor into the trust zone. But actually, nowadays, we have some tools that can utilize. For example, today's IoT devices, they usually come with barcode or QR code, and the devices manufacturers can encode some information into it, like a hardware profile or a public key or a temporary encryption key into it. And the device owner, say Alice, need to scan that code to initiate the bootstrapping. So for the simplest case, we consider if the QR code only contains a temporary encryption key, and this key is for one-time usage and only for the security bootstrapping. So the mutual authentication is achieved as follows. First, the sensor authenticated a smartphone because the smartphone is within, say, 1 meters. So it is only the smartphone can obtain this temporary encryption key. Because the smartphone communicates with the sensor, to the sensor with the encryption key, so the smartphone is authenticated. On the other side, also, the sensor is authenticated because smartphone can recognize, okay, this sensor is communicating with me with the temporary encryption key pre-shared in the QR code. So the mutual authentication in this case between the smartphone and the sensor is achieved by the secure channel. And other mechanism like public key or URL to the manufacturer will achieve the same goal of mutual authentication by securing channels. After the secure channel is established, the smartphone can bootstrap the sensor by, say, making an identity bundle. Well, in this case, the smartphone may ask Alice to assign a name for the sensor, like /Alice/ say a temperature sensor, then making an identity bundle, then deliver this identity bundle to the sensor, and the end-to-end encryption that is established by this encryption key will provide the communication security of this bundle. So that's the local bootstrapping in unsecured environment. But what about a little more different one, a more difficult one, that the entity is at the remote end, which means which can be a remote application instance, and the communication between the trust zone controller and the entity is unsecured. And in this environment, we need to think about how can we securely deliver the identity bundle to the right party, especially how we do the mutual authentication first. So we consider the trust zone controller can only reach the remote, remote entity over the current IP connectivity. And to achieve the mutual authentication between the entity and the controller, we seek into utilizing some existing trust relations or existing authentication solutions. Hopefully, or fortunately, we have lots of options today. We have current security authorities. We have DNCERT, or for today's web application, we have single sign-on for users. So we are assuming, in this case, we are assuming this remote entity Enew is an NDN app running on user's computer. Then the trust zone controller can authenticate this Enew if the current app user of this Enew is authenticated. While on the other side, Enew can authenticate the controller in the software distribution. For example, the application package that implement the logic for installation can contain the trust anchor and the initial trust schema. For example, this initial trust schema can enforces the identity bundle that could be made later must be signed by the trust anchor. So when later Enew receives the identity bundle, it can validate this bundle with the trust anchor and the trust schema that obtained at the software installation time. So in this case, the controller's authenticity is assured by today's web security support. For example, the user fetches her package from a GitHub link, and this GitHub link is trusted. Then the GitHub CA DigiCert will assure the authenticity of this package. We apply this concept of using existing existing authentication system to achieve mutual authentication to an ongoing project we call Hydra, and this is a federated data storage project. In this project, different organizations will contribute file servers to share their data, and user will install the Hydra app on the file server they wish to contribute to the system. And we will have a network operating center serve as the controller for the trust zone Hydra. And you can see in this case, because the Hydra app can access the file server at local, so the Hydra app need to be authenticated, and also the Hydra NOC need to be authenticated by the Hydra app, so it can later deliver the identity bundle to the Hydra app. So we assume the user IDs that actually run the Hydra app on the server has an assigned identifier. For example, if it is a student from UCLA, it may have identifier and under the UCLA campus, the IDs at ucla.edu, and this identifier based on email can be authenticated by current, say, UCLA single sign-on service. Then the campus SSO can generate a security assertion for IDs by cryptographically sending the identifier analyst at ucla.edu with its SSO certificate. So it is the SSO certificate authenticate IDs under this identifier, and we assume this security assertion is IDs existing authentication. On the other side, as we the Hydra NOC needs to obtain the UCLA's SSO certificate out of band by either say contact the operators by emails or downloading the metadata from GitHub. Then the Hydra NOC can authenticate all users from UCLA by accepting the SSO certificate from UCLA server. On the other side, Hydra app authenticate the Hydra NOC at the application installation time, as we just mentioned, and the initial trust anchor and the trust schema embedded will ensure the authenticity of later identity bundle. So although we have mutual authentication, and Hydra NOC need to generate identity bundle for the remote Hydra app. But however, Hydra NOC still needs to know the name that this new entity, and this name should not come from nowhere. So we pull the name from the bootstrapping context of this remote Hydra app. This Enew name will have an application prefix, which will come from the trust anchor, and a unique suffix which do need assignment. So the Hydra app, while starting, can self-obtain a name from the security assertion by use the trust anchor prefix Hydra as the application prefix, then append it with the identifier Alice at ucla.edu to generate a name, to self-obtain a name. Optionally, in this process, the user Alice can decide a new identifier to this remote Hydra app. It all depends on the runtime decision. And with this name self-obtained, the Hydra app can request the identity bundle for the newly obtained entity name. And now mutual authentication is achieved. And then the entity name is self-obtained. The Hydra app can use NDNCERT protocol to request the identity bundle from Hydra NOC with the security assertion attached. For example, first it will send a self-signed certificate to request an identity bundle to the Hydra NOC. Then Hydra NOC say, okay, I received your request. Now I get your property key, but still I need to verify your identity. Then Hydra app receiving this reply will further send another interest to attack with the security assertion attached for this identifier. Then Hydra NOC verifies the security assertion by the pre-configured SSL certificate. Okay, so if the validation is successful, the Hydra NOC can reply with the newly issued identity bundle. And because the remote Hydra app authenticate the trust zone controller or the Hydra NOC by the software distribution, and the Hydra NOC authenticate the identity bundle by the initial trust schema. So later, when Enew receive or the Hydra app receive this identity bundle from Hydra NOC, it can validate it by the trust anchor and initial trust schema that is obtained from the application installation time. So we can see from the later two cases that before the bootstrapping can even start, the controller and Enew, they need to authenticate each other to ensure that each party is the right one to talk with. And the authentication, such authentication are always based on utilizing some existing trust relations. And in the first case, where you use DCT command line tools to configure Office application, this mutual authentication is directly achieved by the direct or physical access. And in the second case, when user Alice wants to configure a sensor and the network environment is unsecured, the physical vicinity, like you have to scan the QR code in person, that restrictions facilitate this mutual authentication. It ensures that only a smartphone can get the temporary encryption key. Well, in the third case, when this Hydra app is remote and only reachable via legacy IP connectivity, the Enew is authenticated by existing authentication system, like the UCLA SSO system give you the identifier as Alice at ucla.edu. And the controller is authenticated by the user or the Enew authenticating the software provider, because you authenticate the GitHub link, and then the security support for GitHub will assure the authenticity of the application package. And after this mutual authentication achieved, the identity bundle created by the trust zone controller can offer the security credentials and initial trust relations after the mutual authentication.